You already know, don't you, that the cosecant is 1 over the sine? Yeah, you already memorized those. So the reciprocal ones are going to be pretty easy for you. You're responsible for the Pythagorean identities. Sine squared plus cosine squared is 1. Now, underneath that one, or next to it, or above it, or wherever you can find room to squeeze it in, I want you to also write this. Since sine squared plus cosine squared is 1, you can rearrange this and say maybe sine squared equals 1 minus cosine squared. See what I did? I subtracted the cosine squared over on this side. So you need to recognize that sine squared is the same as 1 minus cosine squared. And I could do it the other way. Cosine squared is the same as 1 minus sine squared. So add these two. This one's already on your sheet. Add these two right underneath it or next to it or something like that. We're going to use those a lot as we go through our work. So sine squared is the same as 1 minus cosine squared, and cosine squared is the same as 1 minus sine squared. Okay? You are responsible for the co-function identities. Now, let's talk about these. These should be the easiest, but a lot of times kids get confused. So let's talk about them. First of all, what are co-functions? We have sine and cosine. I'm not talking about reciprocals. I'm talking about co-functions. So we have sine and cosine. We have secant and cosecant. And we have tangent and cotangent. These are the co-functions. See how they're paired? Sine, cosine, tan, cotan, secant, cosecant. These are not the reciprocals. We already know what those are. Those are something different. These are specifically called the co-functions. The word C, or the letter CO, stand for complementary. Can anybody remember from geometry what complementary means? No, it's the other one. They add up to 90. The angles add up to 90. Complementary means they add up to 90. So look at your co-function identities. They all have a pi over 2 in them. What's pi? 180. So what's pi over 2? 90. So if you want to change all those pi's over 2's to 90's, you can. But the minute you see a 90 in the problem, you're going to think complementary, and then you're going to think co-function. So if I see a problem that says a sine 90 minus theta, I'm going to see that 90. I'm immediately going to think complementary, co, and the co-function for sine is cosine. It's that easy. So if I see tangent, 90 minus theta, I'm going to see the 90. I'm going to think complementary, co. So tangent, the co-function for tangent is cotangent. Anytime you see a 90, you're going to use the co-function. Okay? When you see a 90, you're going to use the co-function. And then the last group you need to know are the odd and evens. Okay? The odd and evens. Who brought calculators today? I hope you all did, because you thought you were going to take a test. Would you get it out for me? We'll do a little experiment. Make sure you're set in degrees, okay? We're going to be set in degrees. And I'd like you to type this in on your calculator. And then I'd like you to type this in on your calculator. Tell me what happens to the answers. When you type in sine 42, you're going to get something. And then when you type in sine negative 42, you're going to get something. Tell me what happens. Okay?
Just the number's the same, just one has a negative.
Exactly. So in other words, when you put this negative in, when you inputted a negative, it outputted a negative. This is what happens in an odd function, what's called an odd function. An odd function says if you put a negative into your problem, you will get a negative out as the answer. Tangent is the same. It is odd. Put a negative in, get a negative out. Cosecant, same thing. These are all written on your paper, so you don't have to write it down. Cotangent, same thing. What does it mean to be odd? It means if you put a negative in, you get a negative out. A negative inside means a negative outside. Now, do the same thing, only do it with cosine now. Do cosine 42 and cosine negative 42. What happened? They're exactly the same. In other words, when you put a negative in your cosine, it disappeared. That is what it means to be even. And there are only two functions that behave that way. So I would suggest you remember that the negative doesn't matter. The negative doesn't matter on the cosine and secant. Everything else it does. Okay, that's what the even odd identities are. If you input a negative, what happens? If you input a negative here, nothing happens. If you input a negative here, it comes out. Okay? So right now, those are the 5 groups of formulas or identities, rules, theorems, whatever you want to call them, that you need to get memorized. Okay? And again, don't be overwhelmed, because if you just remember how they work, you don't have to physically memorize each line individually. What did I tell you about when you see a 90? What do you think when you see a 90? You think co-function. CO stands for complementary, so you 90, so you think co-function. What's the co-function for tangent? Cotangent. What's the co-function for secant? Cosecant. If you just think about it like that, you don't have to actually memorize every single one. Even odd. Every single one of these functions, if you put a negative in, you get a negative out, except for cosine and secant. So kind of remember that, and you don't have to remember every single line. Okay? Now, let's look at what we're going to be doing with these. Get your note sheets out. Right now, don't care about that. Right now, we're focused on our note sheets. Same packet as before, we're just back a little farther. So we're on page 39
Of the new notes?
of the new notes. I promise I'm going to stop in 9 minutes, and we're going to do a couple quick review problems, okay? For tomorrow's test, to get us back in that groove.
What period we got?
Tomorrow we have,
Normally we got a long period.
but we will not use the whole period for the test. It's the one after.
You can't use the whole period?
No, you can't.
Why?
Because the other class did it.
Yeah, but that,
No, because the other class did it. That's it. It's a 45-minute test. So the extra time we have, we need to learn.
it's already happened my math order.
Turn around. Mason's gonna look where he's gonna look. You're gonna turn around. I know you're probably looking. All right, here we go. We're on page 39.
This is for. Did we get these on Thursday?
No, these are your old note sheets.
Oh.
I had 2 chapters in your
Okay.
note sheets. These are your note sheets. Get them out. They're on page 39. These are the same note sheets we had before. If you were studying for your test, you had these note sheets out. We're just all the way back in 39. I put 2 chapters together on the note sheets. Alright, so we are on our existing note sheets, the old ones that we used for chapter 4. Chapter 4 note sheets, page 39. Because these note sheets are actually chapters 4 and 5. Now, this is probably the hardest thing for some of you that we're going to do this entire year. It really isn't hard, but you do have to have your brain engaged and you have to know your identity. So keep this right by you while we do this. And let's see how this looks.
What is like the zeros they put in front of all like
Okay, this symbol is a Greek letter theta. Theta, that's a theta. Now, it's a variable. So if you don't like sine theta, write sine x, or sine n, or sine something. The letter you use does not matter. Since trigonometry was developed by the Greeks, we often use Greek letters in the, when we do it, like alphas and betas and those things. But again, it's a variable, so just like you can change it in a regular equation, you can change it here. So you can change it all to x's if you want. Now, problem number 1, 5.1, problem number 1. Your job is to simplify this.
What are we doing?
We are on note sheets, page 39, chapter 4, note sheets. Only we're back in chapter 5, part of it. We're on number 39. All right? Now, your job is to simplify this. So what I want you to do is look at it. Can any of you think of anything you could do? They are not like terms. They don't look exactly alike, so you can't add them. They do have something in common, though. What do they both have? A sign. This one actually has 3 of them, and this one has 1 of them. So I'm going to take out a sign. I'm going to factor this problem. All right, so I'm going to pull out the common factor. You already told me they both have a sign in them. So I'm going to pull that out. Okay? Now, I have 3 signs here. If I take one of them out, how many will I have left? So I have sine squared left. So I took out, there were 3 of them here. I took out 1, that leaves me with 2. It's just like in regular arithmetic. If you have a problem like this and you factor out an x, doesn't that leave you with x squared? That's exactly what's happening here. Now, what am I going to be left with here? I'm taking the sign out.
cosine?
So all I'll be left with is the cosine squared. Now look on your green sheet. I think this is there. What is that? They're squared, so it's a Pythagorean identity. What is sine squared plus cosine squared? 1. Oh my gosh. So I got my sine, and all of that is just 1. So what does this simplify down to? Just sine x. That's it. That's the answer. So this big ugly thing, we took out a sign because we had a common factor. Both pieces had a sign. That left us with 2 sines and 2 cosines. But that is 1. It's on your green sheet. Those are called identities. They're true. So that's just a 1. So you have sine times 1, which is just sine. Whew, that's good. Let's try another one. I can't read this one very well. Alright, the next one says secant plus 1, secant minus 1 over sine squared. Alright, it's the last one we're going to do, and then we'll review for a minute. Any ideas how we might start this? Got to put those together. Geechee says this looks like a foiling problem to me. And it is. This is a foiling problem. Okay, don't be frightened by the letters, SEC. That acts just like an X. So you've got X plus 1, X minus 1. So if I FOIL, what do I get when I times these together? Secant squared. Very good. And this is the way I write it. Please, 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 please don't write it this way. Does anybody know why? Why could this be confusing? Because it looks like the X is being squared, and that's not what's being squared. What's being squared is the secant. You're taking secant times secant, so you're squaring the secant. All right, outsides minus secant. I'm multiplying outsides. Now I'm going to do insides and less. Okay, so what did I do? Nothing tricky. What did I do? I FOILed. Now what? These two cancel. So I've got secant squared minus 1 over sine squared. Now, you're brand new at this, so I don't expect this to occur to you, but after we practice a few days, you'll be an old hat at this. On your sheet, look under Pythagorean. Do you see one that says 1 plus tangent squared equals secant squared? You see that under the Pythagorean list? What if I moved this 1 over here? Then it would say tangent squared. I'm moving the 1 over here. I'm going to subtract the 1. So it says tangent squared equals what? Secant squared minus 1? Okay, wait a minute. So tangent squared equals secant squared minus 1? So what do you think I'm going to do with this secant squared minus 1? Turn it into a tangent squared? So right here, I'm going to turn that into tangent squared over sine squared.
How can you do that?
Because it's substitution. This is that, okay, this is what's on your paper.
Right.
If I subtract 1 from both sides, then it looks like this, which means every time I see a secant squared minus 1, it's the same as tangent squared. It's like substitution. I'm substituting it in.
So we have to memorize these
Yeah.
Okay.
Yeah. Yeah.
We're gonna test for this, right?
They will be, not on this test, no, but they'll be on the next test.
Yeah,
Yep.
no, I'm saying the one that
No, you gotta memorize them. That's why we went through that conversation at the beginning to help you. And we'll obviously, we're practicing them right now. All right, so look at what we started with. Look at the mess that we started with. And look now what it is. It looks a lot better now, doesn't it? We simplified it. Okay, so let's pause now. We got a couple minutes before we leave. Tomorrow we'll take our test. Who is still kind of unclear about a certain kind of problem, and we'll practice it right now? Phil? I'm talking about not this. Put this out of your mind for a bit. We're back on chapter 4.
So, a bird is standing on a 40-foot pole.
Okay, a bird is standing on a 40-foot pole. So here's the bird, here's the 40-foot pole.
Staring at a worm.
Looking at the proverbial worm on the ground.
And it's 100 feet away.
From what?
The bird's 100 feet away.
The bird is 100 feet away from the worm. This is where we really have to be careful, because sometimes the worm is 100 feet from the base of the pole. Then it goes down here. And sometimes the worm is 100 feet from the bird. I am so angry. You give that to me. So, Phil, you said the bird was 100 feet from the worm?
Yeah, and
Okay.
then angle of elevation, I think.
And that would be what we would be looking for.
Yeah.
Okay, so what is the angle of elevation of the worm to the bird? Or it might say, what's the angle of depression of the bird to the worm? Same thing. We're going to put it there. Always, always, always.
And it's sine, right?
And sine. So you'll say sine x equals 40 over 100.
Right.
To type it into your calculator, though, because you don't know the angle, you have to use your special sign button. Your special sign button is the button that finds angles for you. So you would second sign 40 over 100.
That's 23.5.
Okay.
So if it were, if the x were on the outside, then it would just be regular sine. Is that what you're saying?
No. Oh, yes. If the x were like out here.
Yeah.
Yes. Then you would know the angle, and you would be setting up something like this then. Okay? So, you're right. If x is on the outside, you're going to use your regular sine, cosine, tangent. If x is inside, if it's an angle, it'll be right here.
But you would set, it would be set up differently.
This one would be a tangent.
Yeah.
You'd say tan 52
If
equals
you look at the 90
40.
degrees.
No, you look at this angle. So that's opposite and this is adjacent. So that would be a tangent problem. You had opposite and hypotenuse, so yours was a sine problem.
Okay.
All right, okay, I will see you guys tomorrow for the test. Sorry about the confusion today. Now, Ethan, I want you to hate yourself.
I typically do, but my phone is vibrating.
I don't care. It should be off.
My iPad's on my
I don't know. Turn your iPad off. Did you turn that off? All right, now you're going to
I'll
F.
serve his detention for him.